DevOps practices. What are these practices and how one should follow it? To understand it, you need to understand the source code management part, where there is a code repository which can be in your GitHub, in your GitLab, in your Bitbucket, any tech stack. Development team checks in their code, commits their code, final code for the delivery. Once you check in their code, there is a process called continuous integration and continuous testing starts automatically. There are 7 steps to this continuous integration pipeline, which we will understand one by one. These are the 7 steps which we will be going through. First is to download the source code. Once your development team checks in your code to your remote repo, you just run git clone, and that will download the entire code base to your build agent or build runner. Your code base is copied from remote repo to your local runner in a checkout mode, which is the write mode, so you can make modification with the code. That is the first step of your CI pipeline. Let's go to the second step, which is running the unit tests. What we do, you can use any sort of tool, NUnit, JUnit, TestNG, and Jasmine, depending on your technology choices. Whatever technology choice you have, whether you are working on Java or .NET or any other technology, you run unit tests, and if your test cases are passed, it will publish a test report and your build will go further. Please make a note, if any step fails in between, your build will fail. You will not be able to deploy that deliverable because build will not get completed. This is about running unit tests. Now let's move to the third part, which is static code analysis. There is a very popular tool called SonarQube, which has open source version as well. What we do from build runner, we submit our code for analysis over HTTPS, and over this SonarQube will scan our code on many parameters. Once our code is scanned, you can also configure a quality gate in your build pipeline. For example, your unit test success rate has to be 100%. Your coverage of new code should be less than equal to 80%. Duplicate line of code should be greater than is equal to 3%. Security rating of new code should be A. Reliability should be A. Maintainability should be A. Once your build passes, your code base passes all these parameters, then only your build will success. Otherwise, it will send a fail flag from the SonarQube server, and SonarQube web UI will be updated with the findings of that scan. This really helps us to take control on the quality of code which we are building. This is the third step. So far, we have downloaded the source code, ran the unit tests, and run the static code analysis tool, which is SonarQube. So we have somewhat identified and maintained the quality of our code. So we are focusing on testing and our code quality. Let's go to the fourth step. Since we are confident now that our code is secure, our code is passing all the set parameter by the team, we will go ahead and build our deliverable, which is again depending on the language. You can choose any tech stack, Apache, Ant, Maven, Gradle, Nant, depending if you're working on .NET or Java, you can choose it. And this artifactory will be used in the next step. So depending on your tech stack, your output will be either enterprise archive, WAR, DLL, exe, or a jar file. It completely depends on the tech stack which you are working on. There's one more additional step while we are dealing with Java. So dependency check is basically a utility that identifies project dependencies and check if there is any known publicly disclosed vulnerability. This can be integrated as SonarQube report as well, to check if there is any vulnerable jar library used in your project or not. This can be done within the CI. This can be done outside CI, because this takes some time to compile. If you don't want to compromise on your CI timeline, you can do it separately after post build activity. For example, there was a log4j vulnerability reported on 13th December 2021. It really rocked the world, and everybody had to fix it. So vulnerabilities like this, you'll be first one to know whenever this happens and flagged. Same thing, dependency check will do. It will check your deliverables, find if any vulnerable jar, it will flag you. This is only for Java based projects. Then we're moving to sixth step, which is the Docker image creation. So benefit of creating Docker image is that you can run anywhere. Since we have our code base compiled, jars are available, we will use Docker file to install all dependencies inside container along with our compiled code base artifacts, so we can run in any environment. So this is a basic Docker file which will install all the dependencies, create Docker build, create a container for us. Once your container is compiled, what you'll do as the next step, you will be submitting it to Artifactory. What is Artifactory? Artifactory is a universal binary repository manager. This can be used to store all your compiled and tested artifacts. It can be a Docker image, your jar file, your config file, your egg file. Artifacts which are tested, scanned, and have passed quality gates becomes the candidate to push to be Artifactory. Now that we have everything in Artifactory, this delivery will be used by continuous deployment job to deploy across environments. This ends the continuous integration and testing phase. And if any delivery that pass all these 6 steps, you can be confident that it is a secure delivery to be deployed across the servers. This ends the CI and CT part. Before we move to continuous deployment part, we need to understand what are environments. Environments are basically same set replica of server, configuration, softwares, and all the dependencies. It's basically 5 stages. So your delivery will be tested between 5 stages. 4, and then 5th is the production. But what is the purpose of these environments? So quickly taking you through them. Development is an environment which has all the auto deploy thing available. Whenever somebody checks in Git, it will be CI pipeline will run and it will be deployed to dev environment. It is mostly unstable and used by development team. Once dev says it is stable, things move to QAT, an environment which is used by testing team to deploy and test artifacts. Third thing is staging, which is the most closer to production in terms of resources, because this is a place where we run our performance and load testing. Once you have sign off in staging by testing team, your delivery goes to UAT. This is basically used by customers and clients only during UAT period. So this can be on and off UAT. Whenever you have UAT window, you will have this environment, otherwise you will not. Once client gives a sign off in UAT, you move to production. This is where actual customer will use the product and provide you the feedback. Now we understood what are the environments. We have a delivery already pushed to Artifactory after CI and it is ready to be deployed. But do we have environments ready? We don't. There comes infrastructure as code. Infrastructure as code is a concept which tells us that whatever infrastructure you are creating, it needs to be in the coded format. Terraform comes as a savior. Terraform is used to create the resources on all cloud providers. In our example, we are looking at Google Cloud. Ansible is used for configuration. What we do, DevOps team or anybody from development team, they'll write a Terraform code, configuration code, check in at GitLab. Then we have Terraform providers. They will take care of, so it's a declarative language. We can have a separate video about that later on. But for now, just understand Terraform is used to create infrastructure. Once you run Terraform apply, this will create a TF state file, which basically stores the status of your infrastructure. So same code can be deployed by environment target. So you can see all the 5 environments have same sort of resources because you are using the same code to deploy across all the environment to create infrastructure. Whatever CI/CD pattern you follow for product, that must be followed for your infrastructure code as well. There shouldn't be any difference because this is also, that's the best way to practice infrastructure as code. If anything happens with your the project, your infrastructure, you can deploy within minutes. You can create infrastructure within minute. You can have configuration ready in your test in your Ansible scripts, and you're ready to go as you did it for your product code in Artifactory. So you have your jar, your Docker image ready, you have your infrastructure ready. Now comes the role of continuous deployment. So we already completed the continuous integration part. We pushed the image to Artifactory. Now there are 3 tools very majorly used for CD, which is GitLab, Excel Deploy, Octopus Deploy. What they do, these tools will help you to deploy these deliverables to these environments, which is QAT. So you can choose a target environment, like deploy this to QAT, deploy this to staging or UAT. When you deploy on QAT, a Selenium test case of integration testing will run. This can be a separate activity. When you deploy on staging, a performance and load testing suite will run. This is to test that how your product will behave when it goes to production. When you go to production, once you get sign off at UAT, you release it to production. The same pipeline which you have written for CD, which is continuous deployment, will be used. Over here, you can run synthetic tests, which is a very small version of testing all connections between the services and resources. You'll also place alerts and monitoring, so you are aware about the issues which is happening before anybody else, your customer, points it out. So that's the role of CD, where you deploy across environments. Anything which is being deployed automatically is called continuous delivery, and when you deploy it manually, it is called to production, is called continuous deployment. Not to get confused with these terms. So that's the role of the CI and CD. Only last thing left for this video is observability. So it's very important to know what is happening in your infrastructure. What is happening? You need to know the logs. So Fluentd, Prometheus are one of the best candidates to show you the logs. So Fluentd will pass the indexes to Elasticsearch. Kibana pulls the indexes from Elasticsearch and shows you the logs. Grafana pulls the stats from Prometheus and from Kubernetes cluster or a VM or anywhere else, and it will show you a KPIs of your resource utilization, so you can improve upon them. If there is any failure, Prometheus alerts will send alerts to you. So yeah, that completes the CI, CD, and infrastructure as code and observability part. Thank you very much for watching the video. Hope this helped you to understand how you should write a CI pipeline, your CD pipeline, write infrastructure as code, and observability. This is the pillar of DevOps. I'll be making separate videos about all the topics. So subscribe to my channel and let's try to learn together. Let me know your comment and your feedback in the comment section. You can also email me or we can connect over LinkedIn. Thank you very much. See you in the next video. Bye-bye.